Hi, this is Denisa, and in this video I'm going to go over how to program the outputs of the polynomial x squared plus x plus 41. I've derived this coding challenge from this website called Codebymath, and Codebymath is a great website for learning how to code in the context of learning math and vice versa. And you should go check it out. Okay, so challenges: print what you get when x squared plus x plus 41 is evaluated for x equals the range of 0 to 100 or so. And we're gonna find out what percentage of the numbers are prime. So just gonna get straight to it. I'm gonna call the variable equation, and we're going to set the equation in. So x to the power of 2 plus x plus 41, and we're going to put that in a for loop to vary x, and for x in range set 100 or so, let's just take 100, and we're going to print out the result of each output. And as you can see here, we can tell that the first few numbers are prime. I think you all know these are primes. 41 isn't divisible by a thing except 1 in itself, but this huge list of numbers can't really tell if they're prime. They look like they could be prime, but you can't really tell. So we're going to make we're going to test if these numbers are prime or not. So we're going to put all of the outputs of equation into an array or a list, and we're going to have a separate array or list for the outputs that are tested to be prime. In doing that, we can divide the length of each array by each other to find the percentage of prime outputs. Okay, so we're going to append, we're going to add each output to this array. Oh no, equation. And then we're going to test if it's prime or not. Okay, so how do you know if a number is prime? So you know it only has 1 and itself as a variable. It only has 1 and itself as a factor. So to go about this by hand, you would count up from 0 to that number and divide that number. Divide that number by counting up from 1 by all of the values up until you reach that number. And if there are any, and if you find that any of those, and if you find that the number can be divisible by any of those numbers, it's not a prime number. And prime numbers have to be more than 1. So we're going to say first, if the output is larger than 1, and we're going to count up from 2 to the number, and we're going to divide that number by all of those values, and if it evaluates as 0, we're going to say, okay, nope, this is not a prime number, and otherwise we're going to add that value to our array of prime outputs. And you can test this by just you can test if this prime testing works by just counting from 0 to 100, so we can see all the primes from 1 to 100. And we're going to, instead of just printing the values, we're going to print out each individual array. So this is the outputs, all of the outputs from the equation, and this will be all of the prime outputs. Okay, so disregard the error up there, but you can see that the first this first for loop counts from 0 to 100 to 99, and then the prime testing tests all these prime numbers, and you can see all of these are prime. 2, 3, 5, 7, 11. We all know those are prime, so it works. We're going to put the equation in again. And we were asked to test what the percentage of these was prime. So we can create a variable that is test this. So the length of the array output, that's how many numbers are in the array, and the length of how many numbers there are that are prime. I'm going to multiply that by 100 to get the percentage. And we're going to print this percentage of the outputs are prime. So 86%. Let's evaluate till 1,000. Will take quite some time because calculating prime numbers does take time. 58.1% of the numbers are prime. I can't really go any larger because it'll take a really long time. But yeah, that's how you do it. You check for a polynomial and check if their outputs are primes. And that's it. Thank you for watching, and go check out the website Codebymath.